It's time for Maths with Mr. Thomas.
Here we go, Chapter 2, Lesson number 2. Fiona Butcher's favourite lesson, the product rule. Oh yeah. So what is the product rule? Well, it's obviously to do with differentiation, and the product rule is used when differentiating two functions that have been multiplied together, i.e. the product of two functions. Such as y equals 3x squared sine x, that's 3x squared times sine x, so it's two functions, both in terms of x, or y equals x squared times 3 minus 4x to the power of 4. Again, we've got two functions there, both in terms of x, that have been multiplied together. So we would have to use the product rule in order to differentiate the result. So, if y equals u dot v, so u dot v means u times v. So these are just going to stand for functions. U is going to be one function, v is going to be another function, and the dot means times. The way you can work out dy by dx is you would have u dash, which is the derivative of u, so if you differentiate u with respect to x, you would times that by v, which is function v as it is, and you would add on u, just function u, times v dash, which is the derivative of function v with respect to x. So dy by dx equals u dash v plus uv dash, where u dash, as I just said, is differentiating u with respect to x, so du by dx, and v dash is dv by dx, so we're differentiating v with respect to x. So really then, the product rule is if you have y equals u dot v, or uv, then dy by dx is found by using u dash v plus u v dash. Let's try some examples. So example 1, differentiate y equals x cubed sine x. Well, before we go straight into dy by dx, the first thing we need to do is we need to think, right, well, what are the two functions that we're multiplying together? Basit, what are they? Yeah, you've got an x cubed times a sine x. So you need one of them to be u and one of them to be v. So you can write down u and v. One of them will be x cubed and the other one will be sine x. From there, after you know u and v, you can work out u dash and v dash. Remember, u dash is just differentiating u with respect to x, v dash is differentiating v with respect to x. So u dash, if you differentiate this, what would you get? Good, you would get 3x squared. And if you differentiate sine x, you would get, good, you get cos x. Remember from higher, sine cos, negative cos. If you differentiate sine, you get cos. Differentiate cos, you get negative sine. Differentiate negative sine, you get negative cos. And differentiate negative cos, you get back to sine. And when you integrate, you just go the other way. So differentiating sine, you get cos, something from higher. dy by dx then, the way you work out dy by dx, if we're using the product rule, well, it's u dash v plus uv dash. So we've got u dash times v, so we've got 3x squared times sine x. And we're wanting to add on u times v dash. So u is x cubed, and we're multiplying that by cos x. So it's x cubed cos x. Would you leave your answer as that? Well, you could, but really, get into the habit of taking out any common factors. You should be doing that because it may help you later on if you get something a bit more complicated. So, factorising, well, the highest common factor here is just going to be x squared, so you can take that outside the brackets, and then we're left with 3 sine x plus x cos x. Let's try another one. Example 2, differentiate y equals x to the power of 4 cos 2x. Again, what's the first thing that you need to do, Danielle? Yeah, perfect. You need to think, right, well, do I have two functions being multiplied together? Yes, you do. They're both in terms of x, so you have to use the product rule. So, the product rule, remember, you're going to write down u and v. So u, Danielle, what do you want u to be? Okay, so we've got x to the power of 4. And v, what do you want v to be? Cos 2x. Good. And after you've worked out u and v, you have to differentiate them. So we will get u dash and v dash. So u dash, if we differentiate x to the power of 4, bring the power down, take 1 off the power, and we get 4x to the power of 3. Differentiating v, so to get v dash, so if you differentiate cos 2x, well, remember cos 2x means cos of 2x, so the 2x is really in brackets. And when you differentiate that, well, differentiating cos, it goes to negative sine, just from higher. But we would also have to multiply by the derivative of what's in the brackets. So we'd end up with negative sine 2x, but you have to differentiate what's in the brackets and multiply by that. Okay, we're applying the chain rule. So we'd have negative 2 sine 2x. After that, to work out dy by dx, well, it's u dash v plus uv dash. So let's sub in some values. So u dash times v is going to be 4x cubed times cos 2x. Add on u times v dash is going to be x to the power of 4 times negative 2 sine 2x. Well, because we're going to multiply and get a negative, let's just write in the negative here. After that, let's put any numbers first. So I suppose we've got the 2. After that, x to the power of 4, we've got that, and we've also got the sine 2x. So u times v dash will give us negative 2 x to the power of 4 and then sine 2x. Really write it in the order so you've got any numbers first, then any x's, and then sine or cos just on the end. From there, don't leave it as that. Take out any common factors. Again, it may help you later on with some of the trickier questions, especially if you get this on the top of a fraction. It may be able to factorise and simplify with something else. So highest common factor here is going to be good, 2x cubed. You can take it 2x cubed as a common factor. And if you do that, it will leave you with 2 cos 2x. Take away x sine 2x. And that will be your answer. So that's the derivative of x to the power of 4 cos 2x. Woo! High five if you got that. Next one. Example 3, y equals x sine x squared. Notice that the x squared is in the brackets there. So to differentiate this, we would be using the product rule. Why would we be using the product rule, Andrew? Yeah, you'd use the product rule because we've got the product of two functions. This here is x, that's going to be a function, and sine of x squared is another function. So we're multiplying two functions together. We're taking the product of two functions. So write down u and a v. So u is going to be what, Andrew? Yeah, u is just going to be x. Good. And v is going to be? Brilliant. Yeah, we've got a sine of x squared. If you do have them back to front, if you get u and v backwards, it makes no difference whatsoever. From here then, work out u dash. So u dash is going to be the derivative of u. So we're differentiating u with respect to x, which will just give us 1. And if we differentiate v, well, if we differentiate sine of x squared, what would we do for that? Yeah, well, first of all, think, right, well, sine, if we differentiate sine, it goes to cos. So we'd have the cos of x squared. But remember the chain rule, you've then got to differentiate what's inside the brackets. So if we differentiate x squared, we get 2x. Good, and you'd multiply by the 2x, which is why we end up with 2x cos of x squared. Remember, we're just applying the chain rule. From there, dy by dx equals, say it with me, u dash v plus uv dash, yeah! And from there, u dash times v, so u dash times v, we've got 1 times sine of x squared, plus u times v dash, so u times v dash is going to be x times 2x cos x squared. And when you write that down, put any numbers first. We've got the x times the x, which will give us x squared, and then I've got the cos of x squared. Any common factors? Well, nope, there's none, so we're leaving it as that. That is our answer. Lovely. Example 4, differentiate y equals x squared cos to the power of 4x. So for this, again, we're applying the product rule because we've got the product of two functions. It's x squared times cos to the power of 4 of x. So for this, we're going to have u and v. So u is going to be x squared. V is going to be cos to the power of 4 of x. How else could you write that? What does that really mean? Yeah, perfect. What that means is cos x all to the power of 4. Work out u dash and v dash then. So we're differentiating. So u dash is going to be the derivative of u. So if we differentiate u with respect to x, we would end up with 2x. And if we differentiate v with respect to x, well, that's when you need to think about it in this form. So to differentiate, well, we've got the brackets involved, so we're applying the chain rule. So Liam, help us out. Good, you'd bring the 4 down, so we'd have a 4 right at the start. After that, well, we'd have cos x to the power of 3. so the power will go down as well. And you want to multiply by the derivative of cos x. So you multiply by the derivative of what's in the brackets. Differentiate cos x, you get negative sin x, so we multiply by that. Again, general. From there then, well, we can take the negative right to the front. We've got cos cubed x times the sin x, and we've also got the negative 4 there. So that is what v dash is going to be. dy by dx equals u dash v plus uv dash. Say it with me. U dash v plus uv dash. That is what dy by dx equals. Start subbing in the values then. U dash times v is going to be 2x times this cos to the power of 4 of x plus u times v dash. So u times v dash, so it's the x squared times this. Because we've got the negative there, we can really get rid of the plus and just write the minus. Number wise, put the numbers first. We've got 4. We're multiplying by the x squared, so put the x squared next, and leave any sign or cos and so on to the end. So we've got the cos cubed x times sin x. After that, just check any common factors here. Well, yes, there are. We could take out a common factor of 2x, and we could also take out a common factor of cos cubed x. From there, what would go in the brackets? Well, 2x times, we've already got the 2x. Cos cubed x times what gives you cos to the power of 4 x? Well, it's going to be cos x. After that, we've got the minus, and we would end up with 2x sin x just on the other side. That will be your answer. Again, just make sure you leave it factorized. Example 5, differentiate y equals x take away 1 squared times 5x take away 4 to the power of 3. So for this one again, why, Fiona, are we using the product rule? Yeah, we've got the product of two functions. We've got x take away 1 squared times 5x take away 4 to the power of 3. One function in terms of x times another function in terms of x means we have to use the product rule. So write down u and v and then work out u dash and v dash. So u in this case is going to be, yeah, you normally just go with whatever's first. So you've got x take away 1 squared and v is going to be 5x take away 4 cubed. Work out u dash and v dash. U dash should be easy enough. We'd bring the power down, so it'd be 2 times x take away 1. That would go to the power of 1, which we don't need to write. And again, we multiply by the derivative of what's in the brackets. But if you differentiate that, you just get 1. So we can really just leave it as that, because we're multiplying it by 1. It'll stay the same. With v dash, again, do the same thing. So you're bringing the power down. So the 3 will go to the front. The 5x take away 4 will end up as being to the power of 2. And again, you multiply by the derivative of what's in the brackets. Differentiate what's inside the brackets, you get 5. So we multiply by 5. From there then, we can simplify that. We've got a 3 and a times 5, which gives us 15 times 5x take away 4 squared. That is what v dash will be. dy by dx will equal what, Danielle? Good, u dash v plus uv dash. From there we can start subbing in different values. So u dash times v will be 2 times the x take away 1 times this up here for v. And then we're adding on u times v dash, so x take away 1 all squared times the 15 bracket 5x take away 4 squared. So we'd end up with that. Where do we go from there? Well, the rule is really to take out any common factors. It makes it far easier than multiplying all of that out. So look for common factors. Well, number-wise, we've got a 2 and a 15. Yeah, we can't take out a common factor there. X take away 1, we've got an x take away 1 and an x take away 1 squared there, so we could take out an x take away 1 as a common factor. 5x take away 4 cubed and 5x take away 4 squared. Well, we could take out 5x take away 4 squared as a common factor. From there then, put the rest into brackets. I'm going to use square brackets because I'm going to have brackets within brackets. So from here, this times what will give me this left hand side. So I've got the x take away 1, so I need the 2 first of all, so you're going to put it in 2. X take away 1 times, well, I've already got the x take 1, and 5x take away 4 squared times what will give me 5x take away 4 cubed, while missing another 5x take away 4. From there, I'm going to write down plus, and I need the 15, so you're going to write down 15. X take away 1 times what to get x take away 1 squared? Well, I need an x take away 1. And 5x take away 4 squared times what gives you the 5x take away 4 squared? Well, we don't need to take anything out there. So close the square brackets. After that, well, you're leaving that first part just as it is, but if you notice this bit in the brackets, you could easily multiply out the brackets and simplify that. You're just going to have x's and numbers. So multiplying out the brackets, you're going to end up with 10x take away 8, add 15x take away 15, and then from there, that will simplify. So that will become 25x take away 23. I'm just leaving the square brackets just so you can see that. It's just this bit on the end. From there then, well, really our answer is going to be, we've got the x take away 1, we've got the 5x take away 4 squared, and we've also got the 25x take away 23. So that is our answer, fully factorised. Example 6. Differentiate y equals x squared times the square root of x squared plus 1 and express your answer as a single fraction in its simplest form. So the first thing for this one, what are you thinking? Yeah, product rule, good. How do you know it's a product rule? Good, because you've got one function in terms of x times another function in terms of x. So this is where you're thinking of u and v. So u, let u equal x squared because we're doing x squared times the rest of it, meaning then the u dash, dead easy, it's just going to give us 2x. So we've got u and u dash. V then is going to be the square root of this x squared plus 1. In order to differentiate that, we want to think about that without the square root sign. So think about it with a fractional index. And what would that fractional index be, Connor? Good. So we've got x squared plus 1 all to the power of 1/2. Perfect. From there, we can easily differentiate. Just remember to apply the chain rule as it says here. So you bring the power down, so we'd have a half times that x squared plus 1 to the power of, take 1 off the power, so half take away 1 is negative a half. But remember to apply the chain rule, multiply by the derivative of what's in the brackets. Differentiate what's in the brackets, that'll give us 2x, so we'd multiply by 2x. Simplify that then, well, you've got the 2 times a half, so that'll disappear, that'll just give you 1. And that'll leave us with, if I move the x to the front, it'll leave me with x times the x squared plus 1 to the power of negative 1/2. From there, you could leave it as that if you want, but I'm going to rewrite that with a positive index. So it'll be x over x squared plus 1 to the power of a half, but then the power of a half just means the square root. So I'd end up with this, x over the square root of x squared plus 1. From there, we've worked out u, we've worked out u dash, worked out v, we've worked out v dash, so we can go straight into dy by dx, u dash v plus uv dash. From there then, u dash times v is going to be 2x times this x squared plus 1 to the power of a half, or leaving out the square root, plus, and then I've got the x squared times this fraction here. So I'd end up with that. So u dash v plus uv dash. From there, where could you go from there? Well, what you want to think is, you're asked to express it as a single fraction in its simplest form. So, to add fractions, we really need fractions. So what we can do is, well, we've got this fraction here, the x squared, we can think of that as x squared over 1 times. So really we're doing the x squared times x, that'll give us an x cubed over the square root of x squared plus 1. And then with this part here, well, we need to think of that as a fraction. So just now it just means over 1 because there's nothing there. So we can write that as 2x times the square root of x squared plus 1 over 1. From there then, where could you go? Well, you need to add the fractions together, and to add them you need the same denominator. So to get the same denominator here, well, here you've got a 1 and here you've got the square root of x squared plus 1. What we really need is the denominator here to also be the square root of x squared plus 1, and you can get that by multiplying the bottom by the square root of x squared plus 1. But if you do that, well, it'll change the fraction. So you also need to multiply the top by the square root of x squared plus 1. So take this fraction on the left and multiply the top and the bottom by the square root of x squared plus 1. Doing that you will get. So we've just taken the square root of x squared plus 1 and the top and the bottom and multiplied the top and the bottom by this. From there then, well, let's try simplifying it. So you've got 2x times the square root of x squared plus 1 times the square root of x squared plus 1. When you've got the square root of the same thing multiplied together, really the square roots will cancel out because you're squaring it. So that will give us 2x times x squared plus 1 over the square root of x squared plus 1 plus, and then this fraction on the right, I've just left that as it is. From there, where could you go from there? Well, you could just add the numerators together now. Just before that, I'm going to multiply the top of the left-hand fraction. So multiplying out the brackets here, I've got 2x cubed, add 2x. Then after that, you would add the numerators together. It doesn't matter if you did it in the step before. That is what you would end up with. And then after that, where could you go? Well, you've got a 2x cubed, and you're adding on an x cubed, which means you've got 3x cubed. Add the 2x over the square root of x squared plus 1. And would you leave it as that? Well, you could do, but again, you're best to factorise. Leave your answer fully factorised. If you get to harder questions, it will make a difference. So, take out a common factor. Common factor in the top is x, so we've got x times the 3x squared add 2 over the square root of x squared plus 1. And that is your final answer. There we go. That is the product rule. Fiona Butchert's favourite lesson. She absolutely loves it. U-V plus UV dash. Good luck. It's page 18 in the Unit 1 workbook. Check your answers as you go. Let me know if you have any problems. Best of luck. See how you are differentiating the product of two functions using the product rule. Enjoy. Bye. U-V plus UV dash. Yeah.